Welcome to you e-learning classes after a vacation. Dear students, now your syllabus is Polynomial, the second chapter in your book. So, in this week, I discuss only about polynomial. This part of polynomial is a part of algebra. Already you have read in junior classes. In this class, first we discuss about polynomial and then types of polynomial. So dear students, what is polynomial? An expression of the form a0 plus a1x plus a2x square plus a3x cube plus dot 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 an xn, where an is not equal to 0 is called a polynomial in x and of degree n, where a is the real number, but it condition that an is not equal to 0. It is a0, a1, a2, a3, an is the real number, but no any number is the 0. Then it is called polynomial, and here 1, 2, 3 are the degree, and it is always in the form of natural number, where n is the natural number. General way you can write that is 3x plus b, it is a polynomial. 3x plus c, 6, it is a polynomial. 6x square plus 5x plus 4, it is a polynomial. You write x square only, it is a polynomial. You write only x, then it is a polynomial. You write only 2, then it is a polynomial. You write only 0, then it is also a polynomial. This is the part of polynomial. Here is only condition: the variable term of x is never in the form of roots. The degree of root x is not like in the fraction, and not in the reciprocal form, and not in the negative. So, and polynomial is an algebraic expression whose degree is non-negative integer also. Its definition in the junior classes, that a polynomial is an algebraic expression whose degree is non-negative integers. Non-negative integers means integers are combination of whole number with negative value 0, 1, 2, 3, 4 dot dot minus 1, minus 2, minus 3 dot dot. It is the integer, but your condition is the degree of polynomial is non-negative integer, that it is not the degree of the polynomial algebraic expression whose degree is only this number. So the degree is 0, 1, 2, 3, 4, etc. Otherwise you can say an algebraic expression whose degree is whole number, that is called polynomial. So there are the 4 conditions. Then you find in your algebraic expression, then it is not a polynomial. I give some examples, like you write here 6x plus 5x. It is not a polynomial because x in the reciprocal form and the degree of this x is minus 1. Similarly, you write 6 root x plus 2. It is not a polynomial because the degree of x is 1 by 2. So, when x in the reciprocal form and the power of x is the fraction form, then you cannot say that it is a polynomial. So, in class 10, you remember it, then an expression of the form a0 plus a1x plus a2x square plus a3x cube plus dot dot anxn, where an is not equal to 0, is called a polynomial in the x degree n. Now, types of polynomial. First, according to the degree, a number in the form of ax plus b, where a and b are real number and a is not equal to 0, then it is called linear polynomial. Dear student, it is in the form of ax plus b, where a and b are real number and a is not equal to 0, it is called linear polynomial. This is 2x plus 3, 5x plus 9, only 6x, it is the example of linear polynomial. Otherwise, a polynomial whose degree is 1, that is called linear polynomial. Second, when you write ax square plus bx plus c, where a is not equal to 0, it is called quadratic polynomial. What is quadratic polynomial? A quadratic polynomial in the form of ax square plus bx plus c, where a is not equal to 0 and a, b, c are real number. Then it is called quadratic polynomial. Otherwise, you can say that polynomial whose degree is 2, that is called quadratic polynomial. You can write 6x square plus 3x plus 4. It is a quadratic polynomial. You write only 3x square plus 4, then it is a quadratic polynomial. You write only 6x square, then it is a quadratic polynomial. You write only x square, then it is a quadratic polynomial. But you write 4x plus 5, then it is not a quadratic polynomial because the degree of this polynomial is 1. It is a linear polynomial. So when degree is 1, that is called linear polynomial. When degree is 2, that is called quadratic polynomial. Similarly, when you write degree ax cube plus bx square plus cx plus d, here a, b, c, d are real number and a is not equal to 0, it is called cubic polynomial. Otherwise, you can say a polynomial whose degree is 3, that is called cubic polynomial. So dear students, where a, b, c, d are real number and a is not equal to 0. b may be 0. You write like as 2x cube plus 3x and these two terms are 0. Then it is quadratic. You write only 6x cube, then it is quadratic. You write, cubic. When you write x, then it is also cubic. But you write x cube plus x square plus 6x plus 8. It is a cubic polynomial where a is 1, b is 2, c is 6 and d is 8. And you write x square plus 5x plus 8. It is not a cubic polynomial because x cube is not present. The degree of this polynomial is only 2. So this is quadratic. It is not a cubic. Similarly, when degree of polynomial is 4, then it is called biquadratic. You write ax4 plus bx cube plus cx square plus dx and plus e. It is the biquadratic where a is not equal to 0. That means you can say a polynomial whose degree is 4, that is called biquadratic. And a polynomial whose degree is 0, that is called constant polynomial. Dear student, you write 6, 8, 2, all are constant polynomial. This 6 you can write 6 into x to the power 0. Then it is 6 into 1 is equal to 6 because the degree of x is 0 and value of this x to the power 0 is 1. So it is 6. So 6 is written as this. That means the degree of polynomial is 0 and this is called constant polynomial. Here is it, you can write x 8 into x to the power 0, that means 8 into 1, that is 8. And here is 2, you write 2 into x to the power 0, that is 2 into 1, that is 2. That means the degree of this polynomial is 0 and it is called constant polynomial. So we can say there are so many examples, all natural number, whole number, all rational numbers, all irrational number, all are the examples of constant polynomial. You can also say that root 2 is the constant polynomial. But root x is the not polynomial. But when you write only root 2, then it is a polynomial. Its degree is 0 and it is called constant polynomial. Now, what is the zero polynomial? Dear students, only one example in your whole syllabus, that is the zero polynomial, that is 0. And the degree of zero polynomial, we cannot define it. What is the degree of the zero polynomial? So, only one example in the whole mathematics, what is the zero polynomial and what is its example? So 0 is the zero polynomial and example is only 0 and we cannot define the degree of this zero polynomial. So according to the degree, there are so many polynomials. First, If degree is 1, that is linear polynomial. If degree is 2, that is quadratic polynomial. If degree is 3, that is cubic polynomial. If degree is 4, that is biquadratic polynomial. If degree is 0, that is called constant polynomial. And if degree we cannot define it, and its example is 0, that is called zero polynomial. Now, according to the term, we can say, suppose here you write 6x squared. It has only one term and it is called monomial. If you write 6x plus 5 and there are two terms, you can say it is binomial. And when you write 6x squared plus 5x plus 4, it will have three terms and we can say it is trinomial. Similarly, you write x cubed plus x squared plus 4x plus 8. The number of terms of this polynomial is 4 and it is called quadrinomial. It is called quadrinomial. So dear student, if only term in polynomial, that is called monomial. If there are two terms in any polynomial, so it is called binomial. If three terms of the any polynomial, then it is called trinomial. And if there are four terms in a polynomial, that is called quadrinomial. So according to the degree, there are 6 types of polynomial, and according to the term, there are 4 types of polynomial, and remaining more than 4 terms, you can say only polynomial. Now I discuss what is the zeros of the polynomial. Zeros of the polynomial. A real number alpha is called a zero of polynomial when px if p alpha is equal to 0. The other name of the zeros of polynomial is the roots. What is the roots of the polynomial? If alpha is any real number and px is a polynomial, then p alpha is equal to 0, then it is zeros of the polynomial. You write here students like as examples. You write px is equal to x plus 3. Then what is the number at the place of x of the real number? Then when we put here and result will be 0. So we can write here is minus 3. Then at the place of x is minus 3 plus 3, that is 0. Then we see minus 3 is equal to 0. So zeros of this polynomial is minus 3. So dear students, what is the zeros of the polynomial? If px is the polynomial, alpha is any real number, and when p alpha is equal to 0, then alpha is the zeros of the polynomial. So we write here example that is px is a polynomial in the form of x plus 3. Then what is the value of real number of x? Then we get the solution will be 0, and that is the minus 3. So minus 3 when substitute their value, then we get answer will be 0. Then it is clear minus 3 is the zeros of the polynomial. Similarly, other example like x squared minus 5x plus 6. It is a polynomial. So what is the value of x when we put here? Then it is the, we get it is equal to 0. Suppose we write here 2. Then it is 2 square. It is 5 into 2. It is plus 6. Then it is 4. It is 10. It is plus 6. Then it is 10 minus 10. That is 0. So 2 is the P2 is equal to 0. P2 is equal to 0. Then 2 is the zeros of the polynomial. Similarly, at this place, when you write minus 3, write here P, x is 3, then you write here 3 square minus 5 into 3 plus 6. So it is 9 minus 15 plus 6. So 9 plus 6 is 15 minus 15 and it's equal to 0. That means when we get P3 is equal to 0, therefore 3 is the zeros of this polynomial. 3 is the roots of this polynomial. How you can find this? Roots and the zeros of the polynomial. So dear student, if your question is here, x square minus 5x plus 6, what is the zeros of this polynomial? So you write it equal to 0, and if factorize it is 3x minus 2x, that is 3 to the 6, and here is plus 6. is equal to 0, x common, then it is x minus 3, minus 2 common, then here is x minus 3, that is 0, here is x minus 2, and there is x minus 3, is equal to 0, so x is equal to 2 and x is equal to 3. So the zeros of this polynomial is 2 and 3. So there are 2 zeros because the polynomial is in the form of quadratic. Then there are 2 zeros, then 2 satisfy, we get 0, and 3 is also satisfy the equation, and we get 0. So we can say that any real number where we substitute as the value of the x in the polynomial, if solution will be 0, that means this real value is the zeros of the polynomial. Then second question, like Px is equal to x plus 3. What is the zeros of this? So similarly, we write x plus 3 is equal to 0. Then x is equal to minus 3. Then you substitute here minus 3. Then you get minus 3 plus 3 is equal to 0. Then it is clear minus 3 is the zeros of the polynomial. So we can say in clear way that any real number when we substitute at the place of x and we get the solution will be 0, then the value of x is the zeros of the polynomial. Now see here, that is what is the relation between the zeros and coefficient of a quadratic polynomial. Dear student, a relation in your book given before the examples, that what is the relation between the zeros and coefficient of a quadratic polynomial. So I write here solution, let alpha and beta are the zeros of the polynomial ax square plus bx plus c where a is not equal to 0. You suppose here that it is a quadratic polynomial, then number of the zeros are 2. So the one name of the zeros is alpha, another name is beta. The other name of the zeros are the roots. So one root is alpha, another root is beta. You suppose here let alpha and beta are the zeros of the given polynomial x square plus bx plus c. It is the general form of the quadratic polynomial, so we write here, where a is not equal to 0. Then it is clear x minus alpha and x minus beta are the factors of this polynomial. That means if 2 zeros are given, then x minus 0 and x minus other 0 is always the factor of the polynomial. So now write here, that is ax square plus bx plus c is equal to x minus alpha into x minus beta into k, where k is the constant. We write here is the polynomial, here is the factor of this polynomial, it is multiplied by k, then we get the polynomial. So this polynomial is equal to the factors of this polynomial multiplied by k. What you get here? Here you get ax square plus bx plus c is equal to x into x square, alpha into x minus alpha x, alpha into beta minus beta x, and minus alpha into minus beta plus alpha beta. Here is k. Then now kx square minus alpha kx minus beta kx plus alpha beta k. Because k multiplies each term, then you get here kx square, alpha kx, beta kx, and alpha beta k. Next ax square bx plus c, kx square and alpha plus beta we take common here minus, then it is alpha plus beta kx plus alpha into beta k, and it is the kx square. Here is ax square and here is kx square. Comparison between them. We write here that ax square and kx square. Comparison between them, then x square cancel, so k is equal to a. This is first equation, you can write that k is equal to a. Second, it is bx and it is alpha plus beta kx. I write here bx minus alpha plus beta kx. X cancel, then minus alpha plus beta b by k. So what is the value of alpha plus beta? Minus here, and k is the a. So alpha plus beta is minus b by a. Alpha plus beta, the relation of the zeros and coefficient is that the sum of the zeros is equal to the coefficient of x and coefficient of x square with negative sign. It is the relation of the zeros and the coefficient. Zeros are alpha beta and coefficient are a, b, c. So the relation between the zeros, the sum of the zeros is equal to the minus b by a. That means coefficient of x by coefficient of x square with negative value. That is the relation between the zeros and the coefficient of the equation. Similarly, here is c and here is alpha beta k. So I write here alpha beta k is equal to c. So alpha into beta is equal to c by k. Hence it is equal to c by a. At the place of k, write a from here. So the relation between product of the two zeros of polynomial is equal to the constant term by coefficient of x square. Constant term by coefficient of x square is equal to the product of the zeros. And related to the problem I solve in the next video. So dear students, the problem of today, you only read the quadratic polynomial and their property from your book, and from next day I solve the examples and the solution how you can solve. Thank you dear students.